Hi, my name's Stuart Lynch, and this is the 5th video in a 7-part series on building a full weather app using WeatherKit. In this video, we'll be adding the final forecast type, and that's to add a 10-day daily forecast to our application. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. If you're working along with me, you can continue on from the source code that you completed in the last video. However, if you're just jumping in here and want to work along, you can download the completed project from that last video. Just make sure you download the branch from video 4. I've already started a branch now for this video, and the completed source code for this video will be in that branch. Links to both branches are in the description. Just remember that you'll need a developer account, and you'll have to change the bundle ID to your own and make sure that WeatherKit is enabled on both the Capabilities and App Services tab for the app identifier for My Weather. I go over all of that in the first video. In this third and final display of weather that I want to implement, it's a daily forecast. WeatherKit will give us a 10-day projection of weather from the API, and this comes in the form of a forecast, which is an array of 10-day weather types. So the first thing I want to do is to go to our Weather Manager class and duplicate that hourly forecast function, but rename it to Daily Forecast. And then we can change the forecast type to a day weather. We'll change the constant name to Daily Forecast. And in Forecast, change to include daily. And then return that daily forecast. As we did in the previous video, let's drill down on this forecast type of day weather to see what it has to offer. This time I get both a high temperature and a low temperature as our unit temperature measurements. I can also get the precipitation and the precipitation chance, and I'm going to use it. I can get the date too. And we can get the symbol name to display that image. That's what I'm going to be using, so let's get started. In Forecast View, I'd like to create a new state property below the hourly forecast, and I'm going to call it Daily Forecast. And it'll be an optional forecast of day weather, just like the other ones. And then, down in the Fetch Weather function, we can update that property by awaiting the call to that new Weather Manager Daily Forecast function, passing in the city's CL location. Now, we're not going to have enough room here in our view to display these 10 days vertically. So I'm going to embed the VStack inside a scroll view. And then I'm going to replace the padding with content margins, all being 15 for the scroll content. Now, because we're in a scroll view, this spacer here is redundant. So here that I want to display my daily forecast within a VStack. So let's add another divider. And I'm going to replace that spacer with an if-let to unwrap the daily forecast. Within here, I'll create a text view that displays the string 10-day forecast. And I'll apply a title font. Then I'm going to create my VStack. And I'll add some padding. And to make sure that my text will stand out, I'm going to apply a background identical to the ones that we've used, which is a rounded rectangle with a corner radius of 20 and with a fill that's a secondary color set to an opacity of 0.2. And then within that VStack, we can use a for each loop that will iterate over each of the daily forecast, and then we can use the date key path again as the ID that will generate that specific day weather instance that we'll call day. Now what I want to display is the day of the week. So I'm going to have to go back to the date extension file and create a new function for that. It's going to have the same signature as the others, so I'm going to call it local weekday for time zone, which is a time zone. And it will return a string. So I'll start by creating a date formatter as before. But for the date format, I'm just going to specify a capital E. And this will display the shortened version of the weekday. Then I'll specify the date formatter's time zone to be the time zone that we pass in. And then we can return the date formatter's string from self. So now that we have that, we can return to the forecast view. And then within the for each loop, I can present a text view displaying the day.dates local weekday for the specified time zone. The days of the week then will be presented vertically, and you can see we can scroll. If you go to your list view and select one of the cities in a time zone that is already in the next day and return, you'll notice that the weekdays are displayed correctly. So here where I am, it's currently a Sunday, but in Sydney, Australia, it's a Monday. Now let's sort out this view. I want to do something like this that Apple does in its weather app. And there might be several different ways to accomplish this, but this is how I'm going to do it. Instead of displaying this day of week here, I'm going to cut this out and create a labeled content view that has content and label that allows us to use views for both. So I'm going to use that same text view as the label. For the content, however, I'm going to create an H stack with a spacing of 0. And then inside the H stack, the image will be a system name using the day.symbol name. And as before, we'll apply a rendering mode of original. I'll set the symbol variant to fill, so we'll get that colored symbol. And I'm going to use a font with a system size of 20. I just realized that this is just like what I did in the hourly forecast view, where I also want to display the precipitation chance if there is a chance of precipitation. So let me go back to the hourly forecast view and grab the code from there, including that if clause. And then I can just return back here and paste it in. I'll just have to change hour to day. And I'm going to apply a font of a system size of 10 to that precipitation. Oh, and I also want to have these both in a V stack, not within an H stack. Notice how the labeled content view pushes the parent V stack out to the edges? Well, after the image, I want to display low and high temperatures. So first, the low temperature. And we can use the Weather Manager's temperature formatter string function from the day low temperature. And then I can set a font to a system size of 12 with a weight of bold. And for the high temperature, I'm just going to copy this same and change it to high. Now, in between these two temperatures, I'm going to display a thin, rounded rectangle that pushes the high out to the trailing edge while keeping the low on the leading edge. So if I use a rounded rectangle with a corner radius of 10, I can apply a fill of a color secondary and set the frame height to 5. And that rounded rectangle will expand to take up as much space as it can get. Well, this is pretty good, but I want to have things all lined up and even like in a table view. So I'm going to let the horizontal bar expand as much as I want, but set fixed widths to the other views. And I can do that with a frame. So for the day of the week label, a frame with a width of 50 and an alignment of leading. For the VStack containing the image and precipitation, I'm going to specify a frame with a width of 25. And then for each of the temperatures, I'll apply a frame with a width of 50. Now they all line up with enough room for the largest temperature, while all of the horizontal bars are exactly the same length without my having to specify a frame width. It'll just expand to the available space. Now this is looking pretty good, but I guess my choice of background for partly cloudy is a little light. I'll leave it to you to change. Well, let me check out the sunny climate like Washington, D.C. I see it's almost good, but the heights of the content aren't even. And I think I've given too much space to the day. So I'm going to change the width of the local weekday label to 40. And then for the entire labeled content view itself, I'm going to set a frame with a height of 35. That should work. Well, now that we have our layout looking pretty good, what I'd like to do then is to overlay a range of temperatures over the bar like Apple does. And the way this works is that we must first determine the minimum and maximum temperatures over the 10 days. So in this example, the minimum is -3 and the maximum is 19. So the range will be 22 degrees, 19 minus -3. The daily date range must fit somewhere within that range. So in the first example of Monday, it starts at 3 degrees and has a maximum of 17. So the length of the bar would be equivalent to 14 degrees, 17 minus 3. But starts 6 degrees in, since +3 is 6 degrees higher than the lowest -3 that we're going to have over that 10-day period. Well, the bar width is uniform between low and high temperatures. So what we need to do is to create a unit that will adjust itself as the device changes within the different iPhone sizes. So for this, we'll need to know the range of temperatures. So the temperature range will be the maximum day temp minus the minimum day temp. And then I can use a degree scale factor to be the bar width divided by the temp range. And then the day range bar width then will be equal to the day high minus day low times that degree factor. And then the offset will simply be the day low for that day minus the minimum day temperature for the 10-day period times that degree factor. So this means we'll need to find values for all of those properties. So let's first start with the maximum and minimum day temperatures to calculate the temperature range. Before the for each loop, I'm going to create a constant called max day temp, and it can be derived by taking the daily forecast and mapping the high temperatures value property and picking the maximum. And since it's an optional, I'll simply nil coalesce to 0. Well, then I can copy this and use it to create a minimum day temperature. I just need to get the low temperature value and pick the minimum. And again, nil coalesce to 0. So our full temperature range for the week, I can create a temp range property by subtracting the minimum day temp from the max day temp. So how do we get the width of that bar? Because it's going to vary depending on the device. Well, you can use a geometry reader and then use a preference key to push that value up the hierarchy to a state property that we can use in our calculations. Now I have a complete video on SwiftUI's preference keys, so I'm not going to go through the details here in this video. I encourage you to watch that video. A link is in the description. What I am going to do, though, is to give you the preference key and view extension that you can use. And you can find this at the gist listed in the description. You can simply download and unzip the zipped version of this file and simply drag it into your extensions folder. So to use this extension, you can just create a state property called bar width that will be a double and initialize it as 0. So we can apply a read size method to the rounded rectangle, and it's going to provide us with a CG size object. And what we want is the width. So we can use that size to extract the width and apply it to the bar width state property. Now, to make things easier to see what I'm doing in code, I'm just going to dismiss this preview and the navigation sidebar so we can see the entire width of my code view. Well, we want to overlay on top of this bar a bar that represents the range of temperatures for any given day, but offset that bar by a number of degrees above the minimum, or to the right or to the trailing edge of the minimum. Well, now on that rounded rectangle, we'll create an overlay. I'm going to create a property for degree factor, which is the bar width divided by the temperature range. And then calculate the day range width. And it can be done by taking the day high temperature value and subtracting the day low temperature value and multiplying that by our degree factor. And then finally, the offset is found by taking the day low temperature value and subtracting the minimum day temperature and multiplying that difference by that degree factor. So we've got all of our properties and everything now. We can, within the overlay, create an H stack. And then create another rounded rectangle with a corner radius of 10. And apply a fill here, but I'm going to make that fill a linear gradient that allows us to specify the gradient colors as well as a start and end point. So for the gradient, I'm going to choose a gradient that applies the array of colors to specify green at the start and orange as the end. And the start point is going to be the leading edge and the end point will be trailing. So let me use a Control M to separate this code so that it's more readable. So we'll set the frame to be a width equal to the day range width and the height to be the same height, which is 5. And then I can add a spacer to the H stack. And then finally, to the H stack, apply the X offset. If I bring back my preview now, I can see that I'm getting the effect that I want. So let me check out Washington, D.C. with the darker, clear forecast. I think I can do a little better here to make things stand out a little bit more. I'm going to change the size of each of the temperatures to 14 and apply a foreground style of white. And I want to lighten up that background bar a little by applying an opacity of 0.1. As I check out my different cities, I think I'm pretty happy with this effect, and I can clearly see which days have a greater range of temperature and when it will be the coldest and the warmest over the next 10 days. Well, one more final thing though. Let's refactor this view out to its own file and apply the same rounded rectangle background to it as we have with those other two different forecasts, the current day and the daily forecast. So cut out everything within the if-let daily forecast clause and create a new file called DailyForecast View. As before, we'll remove the preview. And then I can replace the content of the body with the content of my clipboard. I'll import WeatherKit. We'll need an instance of the Weather Manager's shared singleton. And we'll be passing in a daily forecast, which is a forecast of day weather. The bar width is going to be local to this view, so we'll be able to remove that bar width state property from the forecast view and create it here. But we'll still need to pass in the time zone as a time zone type. Back in forecast view where we cut out the content, I'm going to replace it with the new daily forecast view, passing in the daily forecast and the time zone. And then, as I said, we can delete the bar width state property. Well, that's it for this video, but we still have a couple more things to do. We'll need to be able to add and delete cities of our own choice rather than these hard-coded ones, and I'd like to persist that information to the device so that they'll be there when I launch the app the next time. So if you're enjoying this series, please give the video a thumbs up and leave me a comment, and consider subscribing to my channel so that you know when new videos drop. Thanks for watching.